We are going to end on geometric probability. You've done probability before in your life, most likely, like flipping of a coin or rolling of a dice, or back in elementary school, it was like the probability of the spinner landing on a certain color. With geometric probability, we're going to look at length and areas, finding the probability of something landing on a certain length of a segment or landing in a certain area. By definition, probability, regardless if it's geometric or not, is your favorable outcomes.
This is Carol.
Yep. Over your total possible outcomes. What up?
Right.
He'll be okay right now. Okay, thanks. So, favorable outcomes, I usually refer to that as what you want. Your numerator will always be what you want over the total possible options that there is. So we have this roach that is stuck inside of a box that is 10 inches by 15 inches. And I want to know the probability that it's going to stop in the red region. Probability, what you want over the total possible. Where do I want him to land? In the red region. And what is the red region? A triangle. And if I want it to land in the triangle, what do I need to know about the triangle? The area. Over the total possible. Well, if it's not going to land in the triangle, it's going to land anywhere else in the box, which is a what? A rectangle, right? And it's going to land inside of the rectangle, so inside refers to area. So I need to find the area of the triangle and then put that over the area of the rectangle.
The area of the triangle is 15.
How'd you get that?
1/2 base times height.
And the base is what?
6.
And the height was 5 then?
Yeah.
So then we get an area of 15. Thanks, Kaden. What about the area of our box? 150, because base times height and 10 by 15. It's a fraction. We always have to write our fractions in what? Simplest form, right? Reduce it. What's 15 over 150 reduced to? 1/10. So there's a 1 in 10 chances that our cockroach would land in the triangle versus somewhere else. What's 1/10 as a percent? 10%. What's the probability that he's not going to stop in the red region? 90%. As a decimal, or excuse me, as a fraction, that would be 9/10. So you can write them as fractions or as percents. Your assignment today, the whole backside, I want actually both examples. I want it as a fraction and a percent. Okay. Where did he go? Oh, there he is.
How did you get that to do that? Is it a game?
I don't know, Mrs. Bailey did it.
Like squirt?
Yeah, watch. It's coming. It's just not quite. Oh, there he is.
Oh.
Did you just see him slide down? I don't know where Mrs. Bailey's. Oh, there. Oh, he's back alive. Yeah. There, that's what he's supposed to do. See if his leg flickered too.
That's so
It's like the one cool thing about this smartboard ever. Alright. To your paper, number 1. A gnat lands at random on the edge of the ruler. Find the probability of the gnat that the gnat will land between the points 2 and 10. Okay, so on a ruler, we're thinking length here instead of area. Probability, what you want over the total possible. Well, we want him to land between 2 and 10. Well, that'd give me a length of what? 8. He can land anywhere on our ruler. How long is our ruler? 12 inches, right? No, you gotta add that last inch on there, I mean, even though it doesn't say 12. And then reduce that down. What's 8 over 12 reduced to?
2/3.
2 over 3. So there's a 2 out of 3 chances that he's going to land in the region between 2 and 8, or 2 and 10 versus the whole ruler. Try number 2. a point on segment AB is selected at random, what is the probability that that point is on CD? Probability where you want it over the total possible. So we want the probability of it landing on CD. From C to D, what's the length of that segment? 5. It could land anywhere on AB, so the length of AB is what? 10? So we'd have a 1/2 chance. Do you have numbers on yours? Where's C at? Where's D at? How far is it from 4 to 8? 4, right? The length of 4.
Wait.
So just subtract the values.
I changed my answer because I.
When you, or if you're going to count on your number line, you don't start on 4 and say 1, 2, 3, 4, 5. You go over 1 tick mark. There's 1 tick mark, 2 tick marks, 3 tick marks, 4 tick marks. So 4 out of 10 would be a 2/5 probability. I like seeing some of your faces right there. That was funny.
I was just counting how many dots there were from like C to D.
Well, you can't start on C though. You gotta start on the next dot.
You can, it's just not right.
Yeah, it's just not right. Exactly. So don't do that.
I did it.
Alright, we gotta count the spaces between them. We're gonna skip 3. We're gonna go to number 4. What, Ernie? I don't know. I don't really like that question, how it's worded, so that's why I skip it. Number 4, a circle is inscribed in a square target with 20 centimeter sides. Find the probability that a dart landing randomly within the square does not land within the circle. So how I have it colored up here, we want to find the probability of it landing in that lime green area, the corners. I don't know if you want to shade that a little on yours. We want to figure out what the probability of the dart would be if it lands just in the corners
Why
versus the whole thing.
don't we have that radius line?
Sorry. Because I figured you could draw in your own radius line.
Oh wait, it gives us the radius of the problem.
It gives us the length of the square.
Oh yeah.
So my want is that little green shaded region. How are we gonna find the area, because it got to go inside, of that little green shaded region? Good, find the area of the square and then find the area of the circle and subtract them, you guys agree? That would give me the green part. That's what I want. My denominator is the total possible, so that's always like your outside shape. What's our outside shape, the shape of our target? A square, so we're gonna put that over the area of the square. We'll start with the square. How do you find the area of a square? Base times height, and the base and the height of our square is, and 20 times 20 is, excellent. Area of a circle, pi r squared, and our radius, and 10 squared is, so then that would give us 100 pi. So if I take those and substitute them into my little mapping here on my fraction, that would be 400 minus 100 pi all over 400. In the numerator, can I take 400, bless you, minus 100 pi and make it 300 pi? No, because they don't both have pi's. If I look at all three terms, 400, 100 pi, 400, do all three of them have a common factor? 100. If all three of them have the same common factor, then I need to reduce by that factor. So if I reduce 400 by 100, what do I get? 4. If I reduce 100 by 100, I get 1. And then if I reduce 400 by 100 in the denominator, I get 4. This 4 minus pi over 4 would be the exact probability that I would land in that green region. Whenever you leave pi in your answer, that's the exact. We're going to do this one as a calculators, I want you to calculate the percent. Okay, we'll just do 4 minus pi divided by 4. And then round that. Let's go to the nearest whole number, the nearest percent. You should get about 21%. If you don't, try again. Do 4 minus pi, enter, divided by 4. And then you just move your decimal place over two spots. Questions on that one? Cool. Number 5 at the bottom there. Our dart you throw is equally likely to land at any point on this board. Find the probability of it landing in the shaded region. Don't think so hard on this one. Do I give you any lengths? Okay, so we're not calculating any areas. How many things are shaded? 2. How many total things are there? 6. So then our probability would be 2 out of 6, which is going to reduce to 1/3.
Is it just me or does anybody else see a square?
No, I think it's just a cube.
Yeah, it looks
I see it.
like a cube.
Oh, I get what you're saying. Like 3D.
Yeah.
I get what you're saying. I see now. He said square first, that's 2D, then he said cube, and that's 3D, and then he got everyone on the same page. See if you use the right terminology. Flip it over.
Emily got what I was saying before.
Oh.
Where does the
That's because I saw it first.
I know it's blank. We're gonna do this number 5 on the back side.
That's a square.
A dart you throw is equally likely to land at random on the board shown. I want to find the probability of it landing in the shaded region, and by shaded region, I'm referring to that red figure. So we want it to land in the red polygon. What kind of name could we give that red polygon? From my quad tree. A rhombus, because it has what? 4 equal sides, and I don't know for sure if it's a square because there are no what? Right angles. Good. So we want it to land in the rhombus, but it could land anywhere in that dartboard. So anywhere in the dartboard is referring to the outside shape. That guy's a square because it's x by x, and then there's this little right angle over here, so I know that's a square. Okay, if we want it to land inside, in refers to perimeter or area? Area, right? So I need to figure out what the area of the rhombus is. Do you remember your rhombus formula from last week? 1/2 diagonal 1 times diagonal 2. Good. How long is the vertical diagonal on my rhombus? X. How long is the horizontal diagonal on my rhombus?
X.
X. So then we're going to do 1/2 x times x. You agree? And x times x is x squared. So this is just going to be 1/2 x squared. For my square. And there's multiple ways to find the area of the square, but we could probably go to the basic one. What's your most basic one? Base times height. What's the base length? What's the height? And x times x is, so we've got 1/2 x squared over x squared. What's going to happen to these x squareds? So what's our probability? 1/2. If I gave you dimensions, it was a 5 by 5 square, and you calculated everything plus 2, it would still come out to be 1/2. Questions on geometric probability? All right. We're done. Bless you.